Thanks, Mike. Yeah, I was really excited to see that Tyson will be giving the keynote today. There's few people that I can think of that have more passion related to soil moisture than Tyson Ochsner. So I'm sure every morning he wakes up and goes, soil moisture. That's what got you here. So it's my great pleasure to introduce Dr. Ochsner from Oklahoma State University. Today, he will be giving us a broad perspective on soil moisture information and the USDA Livestock Forage Disaster Program. It's all yours.
Good morning, everyone. Thanks to the organizers of the workshop. I caught the first half of the day yesterday online, had some travel trouble, but really happy to be here in person with you today to talk about soil moisture. It is one of my favorite topics, John, you're correct. So, but before I talk about the I want to acknowledge my co-authors. A lot of the analysis you'll see here is really led by Eric Kruger, who's a senior research specialist in my group there at Oklahoma State, and also our colleague Wade Brorson, who's a Regents professor in ag economics at Oklahoma State. So all the credit to them for this analysis that I'll show you. But before I get to that, I want to talk about this idea of the U.S. National Coordinated Soil Moisture Monitoring Network, which is one of the main things that brings us here together today. And it's awesome to see the progress that's being made, that has been made. It's awesome to see the work that you all are doing towards this vision. And the main thing I want to say about it is that this first line of my slide here does not contain a typo, because the network is really, it's about us as a community, right? That's really what drives all of this. And it's been a huge joy for me to be a part of this, really going back to 2011. So this is a photo from the first MOISST workshop, which stands for the Marena, Oklahoma In Situ Sensor Testbed. And if you look closely, you'll see younger versions of Mike and I there in the photo. In 2011, we had our first workshop in Stillwater, Oklahoma. There were 14 participants, and we had just a great time talking about soil moisture monitoring technologies and how to move them forward. And we said, we have to do this again. And so we did it again in 2012, and we didn't really advertise this, but it grew a little bit. There were 26 participants 2012. And we said, that was awesome. Let's do it again. So 2013, we did it, and there were 28 participants. And then something really important happened in 2013. There was the first workshop for the National Soil Moisture Network in 2013 in Kansas City. Stephen Quarry and others of you here helped to organize that. 2014, we met again in Stillwater, 45 people getting together, sharing ideas. 2015, we met again, 51 people coming together. 2016, we met again, 68 people there sharing these ideas. And again, in 2016, we had a National Soil Moisture Network meeting in Boulder, Colorado. And at that point, it finally hit us like, oh, what are we doing? Let's put these two together and it'll be even better. And so we did. We made these MOISST/NSMN workshops again in Stillwater in 2017. We had 72 participants there. And then 2018, we said, you know what, this is great. Let's move it around the country so more people can be a part of it. So we moved it to Lincoln, Nebraska. In 2018, we had 95 participants there. It was awesome. And then we said, yeah, that name's too complicated. Let's just make it the National Soil Moisture Workshop. And so we did that starting in 2019, Manhattan, Kansas. We had 88 participants there. And then COVID comes. We were planning to come here to DC in 2020, but COVID prevented that. We went online only, but that was maybe a blessing. We had 181 registrants for that meeting. Again, 2021 was all online, 248 registrants. And then we were able finally in 2022 to go back in person. We went to Columbus, Ohio, had 125 registrants for that meeting. And so it has been really cool to see what this has become. It has become a growing community of science and practice. And there is a photo of the group from 2018, which was a really nice group photo that we were able to get. And I think part of the growth can just be explained by the fact that this group, we have a really clear purpose, which is to provide high quality nationwide soil moisture information for the public good. I think that resonates with all of us. This is what we're working towards together. And you know what? We kind of like doing it. So it's been really good, and we're learning things as we go. I want to talk a little bit beyond our purpose and talk about a vision. Okay, so here's a vision that I have, and you see if this resonates with you, okay? I have a vision for a day soon where soil moisture measurements will be as widely available and as readily understood by the public as are measurements of air temperature or precipitation, okay? Think about it. It will be like on the TV news, you'll be just as likely to hear the weatherman report on the current soil moisture levels as on, the day's rainfall or maximum temperatures, right? It'll be just as likely for you to hear a farmer in one county talking to their friend in another county and asking, well, how wet are your soils or how dry are your soils? And they'd be able to respond with some accurate information to that point. Okay, this is the vision that I have, and I think probably some of you have as well. And I think we can do this. We can see this become a reality. So as we move forward in the future, I think there are a lot of opportunities for us together, and I'll just mention a few of them here. And honestly, from the talks yesterday, you're already doing this stuff, so I think it's great. We have the opportunity to go farther. And I mean that in a few different ways. We have the opportunity for this to be not just a US network, but truly a global network, both of infrastructure, technology, but also people working together to pursue this vision. So we can go farther and go international. We can go farther into ecosystems which are relatively unexplored thus far in terms of our understanding of the soil moisture dynamics. We can get beyond, grasslands and rangeland environments, which are easier to work in, to more challenging environments like cropland, like under the forest canopy, wetlands, tundra, deserts, other kind of ecosystems like this. And so I think we have opportunities to go farther together. I think we can go deeper, right? So we have had a lot of work looking at the surface soil moisture conditions. That's important. That's good. But a lot of the cool technologies, I think, are allowing us now to see deeper into the soil, right? Whether that's new proximal or remote sensing, whether that's new installation methods for our sensors, new sensor designs for profiling, all of these kind of technologies are moving forward and allow us to think about not just, the top 10 centimeters, but what if we went down to 100 centimeters or 1,000 centimeters and understand the soil moisture dynamics? I think that will really help us. I think we have the opportunity to look back. Increasingly, we can look back in time. We recently we have a high resolution soil moisture mapping system in Oklahoma State. The data are freely available. We were recently able to extend that back to 1997. Well, that's great. That's 25 years of high resolution soil moisture information. It's all there for anybody to use. But what if we go back further, right? What if we can go back 50 years, 100 years, thousands of years, using appropriate proxies for soil moisture conditions and really get a deeper understanding of the ecosystems and environments that we're working in? I think we have the opportunity to do more of that kind of work. I think we have the opportunity also to increasingly look ahead. Here I'm thinking about soil moisture forecasting, and also climate change projections with valid soil moisture projections in them, right? So this is an area, I think, where we can make some progress, looking at what are the soil moisture conditions going to be in this location next week, or for the coming season, or for the next decade, the next century, right? Because the soil moisture conditions, for example, looking out 50 or 100 years, our research has shown that's going to dramatically impact the soil carbon, right? And the soil carbon then is going to feed back one way or the other, positive or negative, on the climate change itself. So this is an essential part of climate projection, and we have a lot more we can do there, I think. And then finally, I want to say we have an opportunity to continue to increase our focus on people. How do soil moisture conditions impact people's lives? Could it be that soil moisture conditions are an important impact on child development in developing nations? There's some evidence that that's true. Could it be that they're an important impact not only on the financial outcomes for farmers and ranchers or rural communities, but also on psychological well-being, right? How can we use soil moisture information to better predict flash floods or landslides, thereby saving lives? Or, as we've done in our group, to look at wildfire danger and improving those wildfire danger predictions with soil moisture information. I think these are all things that we have the opportunity to do together, and I'm excited about those. But none of those are what I want to talk about today. Today, I want to talk about a multi-billion-dollar impact of soil moisture directly on people's lives that's received very little research to date. Okay, so I want to tell you about it. We've been working on this for a few years now. We've been studying this thing called the Livestock Forage Disaster Program. It is a very helpful and very large federal program. It provides compensation to livestock producers who've suffered grazing losses due to drought or fire. And this program it's relatively new. It was created in the 2008 Farm Bill, okay? And so in the period from 2011 through 2018, there were over $7 billion in payments from this program, all right, in that 8-year period. So that's close to $1 billion a year. Right? How much have we spent on the SMAP mission? I don't know, $1 billion or so. This is $1 billion a year. Okay, so this is a huge program with a huge impact. The #1 state in the nation to receive these payments thus far is Oklahoma at $1.4 billion. Texas, $1.2 billion right behind. So you can see the map there that shows the distribution of the payments nationwide, or the county level map within Oklahoma. And the payments for this program are triggered using the U.S. Drought Monitor, which many of you are familiar with, or you may be involved with. You may help produce this. So the Drought Monitor is a really important product. It's produced there at the University of Nebraska, Lincoln, through the National Drought Mitigation Center and many partners. And it maps drought severity using a convergence of evidence approach, which means they look at a lot of different indicators of drought. Meteorological indicators, agricultural indicators, hydrologic indicators, and they have an expert interpretation overlaid over the top of that and produce these maps every week of drought severity across the U.S. And so since, I think, 2011, these have been used to trigger the LFP payments at the county level. So, and this is the set of rules. If you can see that, sorry, it's a little bit low on the slide, but there are basically 4 different payment levels, which are these multipliers of 1, 3, 4, or 5. So if you have, if your county experiences 8 consecutive weeks of D2 drought, as rated by the Drought Monitor, then that's a payment of 1, which represents 1 month of lost grazing, basically. If you have a D3 drought at any point in your grazing season, then that's a multiplier of 3. If you have D3 drought for 4 consecutive weeks, that's a multiplier of 4. Or if you have D4 drought at any point during the growing season, that's a multiplier of 4. Or the worst case, if you have 4 weeks of D4 drought, whether consecutive or not, that's a multiplier of 5. So what we wanted to know is how well is this payment scheme working? And thankfully, the place where the payments are most concentrated, Oklahoma, is also the place where we happen to have some of the best soil moisture information. So we took a look at this, and we could see that the current payment system is not optimal. It's okay, but it has a couple of deficiencies, which I want to show with the data here. So on the y-axis, we have the hay yield anomaly. We don't routinely measure forage and grazing lands. That's not something we measure, but the same forages can be harvested for hay, and we do have those data. So we have the hay yield anomaly for the 30 top producing counties in Oklahoma over a 19-year period. And then we have the LFP payment multiplier that would have corresponded to that growing season. And so one thing you can see right away is that this payment multiplier of 1 is typically associated with above average forage production. So that's not ideal for a relief program. That's not what we want to do with this program. So that's not ideal. And then the other thing you can see is that these multipliers 3 and 4, where we're having a significant financial impact on people by distinguishing between these 3 and 4, there's really no difference. These are not statistically significant in terms of their impacts on forage production. So these are sort of unjustified differentiations here in the current program. So then we ask, okay, well, what if we use soil moisture information instead of the drought monitor? Because we know that soil moisture regulates forage production during drought. So we took all of the Oklahoma Mesonet soil moisture data, 120 stations, and we represented it in terms of fraction of available water capacity, or FAW, for the 0 to 40 centimeter soil layer. And this FAW is calculated as the current volumetric water content minus the wilting point, okay? And then divide that by the difference between the field capacity and the wilting point. And so it's basically, what percentage of the tank is filled right now is one way to think of it. And then we calculated the FAW anomaly for every day of the year based on the long-term data. And we could see that this FAW anomaly provides a potentially more effective basis for these LFP payments. And so I'll show you the data. So here we have the hay yield anomaly again on the top y-axis, and the FAW anomaly on the on the x-axis there. And you can see it's a breakpoint kind of relationship. This is exactly what we would expect from what we know about plant physiology, would be some kind of relationship like this. And so based on that relationship, then we can propose these alternative, payment multipliers. Sorry if that's a little bit too low for you, but basically on the far right, so where we have FAW anomalies that are greater than -0.1, then we don't need a payment, right? Those are years of good forage production. If we have FAW anomaly that's between -0.1 and -0.25, then we're proposing a multiplier of 1. If we keep coming to the left, we have a FAW anomaly between -0.35 and -0.25, then that's a multiplier of 3. And less than -0.35, those are the worst case scenarios, that's a multiplier of 5. And all of those are statistically significant differences in the outcomes that people experienced. And so we can justify these 3 different payment levels. Okay, so these are our proposed multipliers to apply to this data set. And now we apply those backwards in time. We see how it comes out. And we see on all the measures we looked at, there are improved outcomes when we use soil moisture information rather than the drought monitor. So for example, look at this multiplier of 1. That's the least severe drought impact. That should happen more frequently than a more severe impact, right? That's how these things work. And so we see that's the case here for the soil moisture based indicator. We have 16% of the time where we're at this level 1 impact, and only 8% of the time we're at a level 3 or 5. compare that to the current drought monitor-based system. It has this odd behavior in that we're at level 1 only 3% of the time, but we're at level 4 10% of the time. So that doesn't really make sense. But that's just the way the system's working currently. So we see an advantage there. And then also there's broader participation if we use the soil moisture-based indicator. If you add up these percentages, 8 and 8 and 16, that's 32, right? % of the time, there will be a qualifying event. Whereas under the drought monitor-based system, it's 25% of the time. Okay, so there's some advantages that we see here if we use the soil moisture-based approach. Likewise, we can look at it from an economic perspective, and we ask, how much have we reduced the risk for the producers? So we can just look at this line, losses without payments. We don't want this to happen. So a loss here means that the expected profit to the producer is more than 15% below average. Okay, so these are losses that are happening. If there's no program, that happens 23% of the time. With the current program, we're not doing bad. We're reducing that to 7.8% of the time. So that's adding some value there. If we instead use soil moisture information, we would further reduce that to about 6%. So that difference from 7.8 to 6, that's about a 23% reduction in the risk. So that's good. This target deviation risk measure, I don't have time to explain it all, but this is basically an economic impact. We want it to be 0. Without the program, it's 12.8. With the program, we reduce it to 2 currently. That's not bad. If we use soil moisture information instead, we'd further reduce that to this 157. Again, it's about 24% reduction. So basically, if we use soil moisture information directly, we'd have 23% less, a lower loss of risk without payment, and a 24% reduction in the total economic impact of these events. So that's great. That's what we want to achieve, and all without changing the total cost of the program. All of this applies a rating so that the total dollar amount for the program is exactly the same. It's just more appropriately distributed. So take-home messages as I conclude here. Under the current system, the payments for D2 drought appear to be unwarranted, as is the distinction between multipliers 3 and 4. Soil moisture data would provide us a more objective and effective basis for assigning these payments than does the drought monitor, at least in Oklahoma. And just think about this, okay? I said 23, 24% benefit. Let's say we just conservatively call it 20%. Okay, so if we improve the efficiency of this program 20%, it's about $1 billion a year. That's $200 million per year. What if we just captured 10% of that? What if we had $20 million to invest in providing this kind of soil moisture information that's needed? $20 million, we could have a soil moisture monitoring stations in every county across this nation, and we could put together really great products based on that would support objective decision-making for the benefit of people, as shown here in the photo. You don't see the person there, but I can tell you behind that photo is a person who is really under severe stress, because that is a failed cotton crop. That is not something that cattle eat normally. Okay, this is a desperate measure. This is in my home county. I know these people. And when the pasture fails and the crops fail in the same year, and you've spent decades developing your cattle genetics, you don't want to send them all to the sale barn, and you put them out to try to survive on cotton stalks. Okay, we can do something about that. Thanks.
Yeah. Thanks, Tyson. Questions? Mike in the back of the room. Peter.
Yeah, thanks, Tyson. That was awesome. You mentioned that the data that you showed were based off of the top 30 counties for hay yield, right? So thinking about Oklahoma, you have a range from the panhandle where you get 15 inches of precip on average in a year to the southeast portion where you get, what, 70. Did those top 30 counties have a bias towards the east or west end of the state?
Thanks, Peter. It's a great question. And so they are slightly biased towards the east, as you are perceiving by your question, that there's more rainfall and we get more forage production over there. We also have more cropland in the west, so the forage tends to be more towards the east. So that's a great question. Yeah.
Yeah, your results with the break point were really cool. I wonder if we were to do the same thing in eastern Colorado, if we'd find there was no break point since we're so much drier, the wet years just get better and better. I don't know.
Yes, it's a great point. There is definitely a range of soil moisture conditions where you have just a linear increase of forage with soil moisture. But then if you get wet enough, then yeah, you would have some kind of break point to that relationship. But maybe in eastern Colorado, you don't ever get there. With that in mind, I will just say that everything I showed was on an anomaly basis. So it was all relative to the average conditions for that county, relative to both the average forage production and average soil moisture for that county. Cool.
I just want to mention online, Mark Brusberg, Chief Meteorologist for USDA, said that although Congress sets the formula, I'd like to share this presentation with leadership at our Farm Service Agency. So what's going on here is going to carry forward into decision makers, or at least decision influencers, still not Congress, but.
That's so funny that Mark said that, because I'm Stephanie Conley and I'm working as Mark's assistant currently on a detail and office of the chief economist. And when you were actually able to put a dollar amount and say for every county, have we ever put that together as a executive committee as a formal proposal to like upper level USDA, to the undersecretary's office?
Thanks, Stephanie. No, I don't think we have, to my knowledge, but
I think
yeah,
that's
hopefully I wasn't out of line there, but yeah, I don't think we have formally done that, but we certainly could put together a cost estimate. Absolutely.
Yeah, I think I think those numbers, hard numbers on paper, because when I gave a presentation to the Office of Science, Technology and Policy at the White House and was able to, based on some of the numbers Mike had provided me for what it would take to fund RAWs to do the same thing, of course they said, yes, this is exactly what we want to do. I never saw that fund because I think it got swept up with the bipartisan infrastructure legislation and it went out other places. But I think that this is something that we should take on as an executive committee and make a formal proposal, line that out, make it polishable, and then follow up on what Mark's online message has said, because I think that that is something that is tangible and fundable. So.
Thanks, Stephanie.
I have a question about whether you're going to, if this were to go forward, would you need to hire a lot of social scientists? Because there's going to be winners and losers as far as people, ranchers who have gotten used to dealing with this livestock issue. Whenever the drought monitor lines move, they are inundated with angry producers who suddenly their property falls across the line, or their neighbor gets the funds for drought and they didn't. And yet, of course, because the resolution is quite different, those lines end up being, I don't know, 70 miles wide or something. Somebody figured it out. There's a lot of people who are concerned out there. So while this is really important that Farm Services be aware of this, I think there needs to be a lot more discussion. I mean, what was said about Colorado back there is one thing, and the same thing as Oklahoma may be true in Kansas and Nebraska, because their precip distribution is almost the same. The far west is 15 or less inches, and the east is not 70, but it's certainly much higher. So there's a lot of underlying issues associated with this. In addition, I believe the Farm Services Agency puts money out to the states, and it's not a national thing that everybody gets the same amount. So there will, within a state, there will be issues with the funding itself. as to how it's distributed. So there's a lot of undercurrents that would be associated with this, but it's really a nice approach. It's much more quantifiable.
Yeah.
Because that's what we need. I mean, the same thing with the drought monitor. It's kind of a gray area in many respects when
Yeah.
people are getting money for drought. So this idea moving forward needs to be presented as a much more quantifiable, reproducible approach.
Yes, yes, absolutely. I think to the extent that we are seeking to be good stewards of public dollars and public trust, that our programs ought to be based on objective data to the extent possible. And this is a step towards that direction, perhaps. And as you rightly point out, there's a lot of education. There's a lot of outreach that's needed. I've spent quite a bit of time through this Rural Renewal Initiative. You can see at the bottom of the slide here, meeting with people in rural areas, going and asking them, what are the federal policies that are affecting your life as a farmer, a rancher, or a resource manager? And two that come up most often are this one, the Livestock Forage Program, and crop insurance.
Yeah.
Those two are huge.
All right, I'm Pam Knox from Georgia, and this probably gets more phone calls in my inbox than anything else. In Georgia, they're very frustrated because they almost never make even the first category, because even though it's really hot, we might not get rain for a month.
Yeah.
It's based on precip and it's based on longer term precip. So the
Yes.
drought monitor doesn't work for us for flash drought.
Yeah.
And so constantly people are calling me, and of course they're trying to call the drought monitor authors too,
Yes.
to get them to change that. So I appreciate the fact that you're using soil moisture, which not only includes precip, but also includes the effects of temperature,
Yes.
and soil holding capacity, which is also another issue in Georgia. Another thing that really hinders us is the fact that Georgia has very small counties compared to other parts of the country. We have 159 counties.
Right.
So when they administer it based on county and next door county, it's a much smaller area in Georgia than it is even in Alabama, where the counties are probably twice as big. So I'd like to really see them get away from using that kind of thing. I know it's easy to administer because it's county, but it does have some disadvantages for counties that are small.
Yes, thank you. And so I could learn more from you. And so thank you for your comments there. And I just want to say, maybe as I'm I don't have anything to do with the drought monitor. So one thing I want to say is the drought monitor works great. The drought monitor is an awesome tool that's designed to be an integrative measure of agricultural, meteorological, and hydrological drought all put together into one indicator. It's awesome for that. I think it's the best thing we have. That's different from an indicator that's designed to represent forage production, right? It just has a different mission. It wasn't designed for this. So it's awesome for what it was designed to do.
This will be our last question. Ken?
Thanks, Tyson. That's a great presentation. I appreciate your energy in changing the narrative, and I share your interest in getting soil moisture in the news more as a more regularly cited weather or climate property. And I just wanted to share like a mini victory we had in Utah, and that's that the lead hydrologist or the face of the snow survey in Utah is Jordan Clayton, whom you know and has worked with this group. He and I are both dirt nerds, and we've worked through the period of record data for all the underground data for the SNOTEL sites in Utah, and it's allowed us to do some pretty interesting things, including, it's especially incorporating that more and more in our stream flow forecasting, which is what the snow survey program does. It's not a snow pack monitoring system. It's really a stream flow forecasting system. So when Jordan got the job as the lead hydrologist, he had started to pepper in and then forcefully add soil moisture as the data element in any discussion. And whenever I've had the chance to interact with the press or the public, I mention it also. And anyway, it's working. It's working great. And I've got two pieces of evidence just to show you. One is that in a recent interview that Jordan had at the office, he had forgotten to mention soil moisture conditions, and that the anchor person, the interviewee, said, "But what about soil moisture?" So he actually asked about it. So it's awesome. You've really made a change. The other thing is a recent article this spring in August. Excuse me, it was last year, August, when we were in a drought, prior to our big snow here this year. KSL News, it's our NBC affiliate, Salt Lake. Soil moisture, snowpack, and runoff are the 3 ingredients needed to end this drought. So it's the lead of that article. Anyway, so it can happen. We just have to, we've linked it as an important component as the first reservoir to fill in that stream flow prediction.
Yeah, that's awesome. Thank you, Kent. And thanks to all of you. I mean, all of you you're making this happen, and you're making the progress happen. So kudos. And I'm just happy to be part of the group.
Thanks, Tyson. We have one last comment from Marena.
Yeah, just because we have a little bit of extra time, the first speaker on the schedule wasn't able to join us, so we're almost back on regular track. But just one thing I wanted to mention, many of you know that last year we initiated a national soil and moisture community leadership award, and Mike Kosh received it. And going into this year, we were very late in organizing. But when we talked about it at the organizing committee, we thought, well, we really need a more organized process going forward so people can nominate, et cetera. So we're going to hold on that until next year. But we decided this year we knew who we wanted to give the next award to, and that is Tyson Ochsner. And so just want to give him.
That's not what you told me.
I know. I lied to him. I lied to him. Okay. I lied to him. Tyson, of course, like you guys are all so great. I'm just such a great community. But Tyson, early on this year, or I guess this summer, said, "Are we going to do that leadership award again? Because if so, I know who's going to get it, and we'll save that for next year." But I told him, "Well, I don't know if we're going to get around to organizing," just like I told you just moments ago. And so we in the organizing committee said, we're going to give it to Tyson. We don't care that he's nominated someone else. So anyway, I lied to him. I told him, no, we're skipping it, but we couldn't think of a better person to get it this year. So anyway, thank you very much you all saw with that talk, the kind of community building and focus, moving research forward into action that this guy pulls off. So we really very much appreciate it.
Thank you. Thanks, Marina. Oh, thank you.
Todd Caldwell, we need a picture. Did you get it?
I don't. I always thought Marina was honest. You've always told me the truth before.
Yes, and I will going forward.
Okay. Thank you.